Before we start talking about prime factorization, I wanted to do a quick review on prime and composite numbers. I want to make sure we are clear on what numbers are considered prime and what numbers are considered composite, because with prime factorization, we are using prime numbers, so we need to know what is what. Okay, I practiced this word the other day, and I don't know if I'm going to say it right. The sieve of Okay, so guys, here's my moment of truth. I had no idea how to say that, and I Googled it. Hold on. I Googled it, and I was sitting at my table in my house, and I said it over and over, and my husband was like, "What are you doing?" I was like, "I'm practicing saying this so I don't butcher it." And now I can't say it, and I practiced and I practiced, and I can't say it. But the important thing, we're starting. The important thing I want you to notice is a sieve, okay? So a sieve is something that you use a lot of times in cooking. If you've ever baked, sieve. They say the sieve. When they were saying it, they were saying sieve. The sieve of it was like a man saying it. Eratosthenes. I don't know. Anyway, so a sieve or sieve is basically like a little thing that you hold and you sift flour through it. It's like a little sifter type thing. Okay, it sifts out all the good stuff, keeps all the things you don't need. Okay, so it's like see that little blank there by our diagram up in the top right? We're going to fill in that blank. I'm going to use red so it pops out. It's like a net for sifting. Why is it not writing? There we go. So the word that I'm having a hard time saying right now is a simple ancient algorithm. What's an algorithm?
It's a way to figure out something.
It's a way to figure out something. Kind of like a set of rules sometimes.
Did I spell it right?
I'm going to wait for just a second. It is a simple ancient algorithm for finding all prime numbers. So the method, how do you do it? You cross out any number that is not prime and you circle all of the prime numbers. So first step, we're going to cross out 1. Why would we cross out 1? It's not greater than 1. Okay? 1 is not greater than 1. And we're going to talk about 1 here in a minute because 1's kind of special. Number 2, we circle 2. 2 is considered a prime number, and it's special because it's the only even number that is prime, because every even number that's greater than 2 can be divisible by 2. Okay? So 2 is considered prime. So if we're already starting to get confused, let's jump to the bottom and let's talk about what the difference is between prime and composite. Okay? A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. Has exactly 2 factors, 1 and itself. A composite number is a number having more than 2 factors. So 2 is special because it's the only even number that only has 2 factors, 1 and itself. Every other even number is divisible by 1 and itself, and also 2 and something else. Okay, so back to step number 2 over here on the side. It says circle 2. Cross out all multiples of 2. So we're going to skip count by 2. So now we're going to mark out all of my multiples of 2. Because every single multiple of 2 can be divided by 2, so therefore it is not considered prime.
So every single odd number.
Every single even number.
Yeah, I meant even.
Every even number will be crossed out. Every even number. Every single even number can be divided by 1 and itself and also 2.
Even. Wait, why are we crossing out the even numbers? Even.
Because they are composite. We're circling our prime numbers. Remember, it says circle prime numbers. That's the whole method. So the only even number that is prime is 2. So it is circled. It is our first number that is considered prime. We didn't circle 1. 1 is special. Anybody know why we didn't circle 1? Milo.
Because 1 is not greater than 1.
1 is not greater than 1. It is neither prime nor composite. It's special. It's just 1. It's not greater than 1. So it is not considered prime. It's also not considered composite. Okay, then we're going to circle 3, and we're going to cross out all of the multiples of 3. Why would I cross out all of my multiples of 3? They can be divided by 1 and itself, but also 3. Because if it's a multiple of 3, it can be divided by 3. So we're going to skip count by 3. So 3, 6 is already done. 9, 12, 15. You are crossing out all multiples of 3. I'll make it a little bit bigger so y'all can maybe see better. No, you can't just go straight down in a line for multiples of 3. It won't work that way.
You just count 3 to the next.
Actually, 37. Oh yeah, I'm so stupid. 37. 75.
Wait, no. That one's not it. Got ahead of myself. 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, and 99. Okay. The next one I'm going to circle is 5. But what am I going to cross out? All multiples of 5.
That's insane, bro.
So all of the numbers that end in 5s and 0s, but they're already marked out because those are also evens. Then we're going to circle 7. And we're going to cross out all multiples of 7. 7 is prime.
7 is special. 7 I'm still. I can't really tell what I'm looking at. It just kind of looks blurry to me. All the
Okay,
multiples of 7
just
are already crossed
make sure your circles are really bright. You can use a color pencil too.
Oh, I died. 21. 21, 37. Oh my gosh, bro.
Okay. To save time, you're kind of noticing the pattern. So what I'm going to do is I'm going to circle all the rest of my prime numbers. So you can just see the primes and go ahead and circle them or mark them. Okay? Starting with 11, 31. I'm just going to go down the first column. I'm just going straight down the first column for right now. I'm just going down the first column for right now. It's not 1. We didn't finish everything. Okay, in the third column, 13, 23, 43, 53, 73, 83. Under the 7 column, We have 7 and 17, 37, 47, 67. Just worry about circling your prime numbers. And then 97. And under the 9 column, we have 19, 29, 59, 79, and 89. And that's it. Close your journal and put it back on the shelf and you're dismissed. So today we're talking about prime factorization, but before we do, we need to just review the difference between prime and composite numbers. So real quick, I practiced this E word over and over and I still can't say it. So we're going to talk about the sieve of E, okay? It is an ancient algorithm. What is an algorithm? Yes.
Like, wait, kind of like the things you do in order to get it done.
Yeah, it's like a set of rules on how to solve a problem. Okay, algorithm is like step-by-step rules on how to solve a problem. Okay, so it is a simple ancient algorithm for finding all prime numbers, and we're going to do it in just a second. But what is a sieve or a sieve? Okay, a sieve is like a net for sifting. So if you have ever baked or helped your parents bake something, you may have had to use a sifter, and you've had to sift flour before to make a cake or to make some bread or something like that. Okay, so you can imagine this sifting all of my numbers, and I'm just filtering out the prime numbers. So we're going to use this method that's listed on your page to figure out all my prime numbers. So I'm going to use a little highlighter, but before we get to all of the numbers, just real quick, let's review. Okay, at the very bottom, it gives us definitions. A prime number is a whole number that is greater than 1 that has exactly 2 factors, 1 and itself. A composite number is a number having more than 2 factors. It's 1 and itself, but also at least one other number. Okay? Factors are numbers that you multiply together to give you a multiple. Just refreshing our minds on that. So now we're going to use this sieve method, and we're going to get all of our prime numbers. So step 1, up at the top, says cross out 1. But notice, before we even get there, it says we are marking out any numbers that are not prime. We are circling the prime numbers, okay? So we're going to mark out any number that is not prime. We're going to circle the prime numbers. So number 1 says cross out 1. Why would we cross out 1? Because it's not greater than 1. It is 1. So 1 is kind of special because it is neither prime nor composite. If you ever see a question that says, list prime or composite, and they give you 1, it's neither. You just put neither. It's kind of like a trick question. It's neither prime nor composite. Okay, it's just 1, it's special. Okay, why would I circle 2? Because it's only divisible by 1 in itself. 2 is also special. 2 is special because it is the only even number that is prime. Every other even number is composite automatically. Because why? If you think about our divisibility rules, every even number can be divided by 2. So it's divisible by 1 in itself, but also 2. But 2 is the only one that only has 2 factors. Okay. We're going to cross out every other multiple of 2. So we're just skip counting by 2s. So cross out every single multiple of 2.
Or maybe just the evens.
All even numbers.
So it'll make a little pattern.
It does make a pattern. Okay, step 3 says circle 3 and then cross out all of the multiples of 3. So 3 is my next prime number. And then I'm going to cross out all of the multiples of 3 because now all of the multiples of 3 can be divided by 1 in itself and also 3. So I'm just skip counting by 3s. 3, 6 is already out. 9, 12. Keep going. Remember, numbers are divisible by 3 if you add the two digits together, and you can divide that sum by 3. So like 51, 5 plus 1 is 6. I can divide 6 by 3.
51. Oh, no.
Okay, 57, because 5 plus 7 is 12, and I can divide 12 by 3. 60 is already out, 63. 66 is already out, 69. 72 is already out, because 7 plus 2 is 9. You can divide 9 by 3. We're practicing these divisibility rules really well right now. 75, 7 plus 5 is 12. You can divide 12 by 3, so that means 75 is divisible by 3. 78 is already out. 81, 8 plus 1 is 9. Can be divided by 3. 8 plus 7 is 15. 15 can be divided by 3. 9 plus 3 is 12, which can be divided by 3. And then 99 is also divisible by 3. Okay, next, number 4. Says circle 5, because 5 is prime. And then cross out all multiples of 5. So all numbers that end in a 5 or a 0 that aren't already marked out, you want to mark those out. So that should be 25, 35, 55, 65, 85, and 95.
Is that a lot of
Step 5, guys, this is the only time you're ever going to have to do this, and then you will have all of your prime numbers through 100 at least circled on this page, and you can reference this page. It's the only time you have to do this method. Okay, number 5 says circle 7 and cross out all multiples of 7. 7 is a prime number, and then we're skip counting by 7s. So 7, 14, 21's already out, 28's already out, 35's already out, 42's already out, 56 is already out, 49 is not marked out, so mark out 49. 63 is marked out, 70 is marked out, 77, cross that one out. 84 is already marked out, and then the next one would be 91 we need to mark out. And 98 is already marked out. Then you go down, and it says circle all remaining numbers. All numbers that are left are prime. So all of the remaining numbers are considered prime. So 11, 17, 19, 29, 31, 37, 41, 47. Oops, I forgot 43. 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97.
What about 13?
Did I skip 13? Oh, I sure did, and 23. Thank you, almost missed those. I was about to just go back and go make sure I didn't leave any out. I think I have them all now.
53 and 60.
Okay, so today is our new lesson, which is prime factorization. It's one of my favorite things to do. It's super fun. I'm going to teach you 2 different methods of doing it. There are 2 ways. So we're going to get these notes in so that you have these step-by-step and examples, and then we're going to do our lesson practice from the book so that you have even more. Okay, we're going to feel really good about prime factorization. So prime number, again, is a number greater than 1 and has exactly 2 factors, one in itself. Prime numbers are the building blocks of all numbers. So prime factorization is when I take a large number and I find factors of it, and I find more factors of those factors and more factors of those factors until I get all the way down to the prime numbers. That's prime factorization. So I have 2 ways to do it. One is the ladder diagram. I like to call it the upside down wedding cake because it looks like a wedding cake flipped upside down. So that's one way. The other way is a tree diagram. I want you to pick what you like and you just stick with that, okay? So you'll see the tree diagram again later in our book lesson, but I'm gonna show you both of these. So the first thing that we need to do is figure out if I'm doing the prime factorization of 600. Okay, I'm gonna start with 600 at the top. We're gonna do the ladder diagram first. What does that look like? If I were to flip it upside down, it almost kind of looks like a division bar, right? It's kind of what I'm doing. So I'm kind of dividing. 600 is even, so that means I can divide it by 2. So it's like an upside down division problem. And I'm factoring it down. So it goes down kind of like a pizza, kind of like how we did with order of operations. It's going down. So 600 divided by 2 is 300. 300 divided by 2 is 150. I could divide 150 by 5. Or 3. There's lots of factors, right? If I divide it by 5, I'm going to be left with 75.
Okay, we're going to do 75.
Sorry, I mean 2.
Yeah.
I'm jumping ahead. I'm so sorry. 150 divided by 2 is 75. Now I want to divide by 5.
Now you're
75 divided by 5 is 15. I could also have done 75 divided by 3 to get 25. Or I could have done 75 divided by 25 if I wanted to. But I like to use small numbers. Okay, now 15 divided by 3 is 5. Or I could have done 15 divided by 5 is 3. It doesn't really matter because I'm going to take all of these numbers. Kind of makes like a little hockey stick. And this is my prime factorization. Okay, so we are going to list all of my prime numbers. So it's like this: 2 times 2 times 2, because I'm just going down. 2 times 2 times 2 times 5 times 3 times 5. Okay, and what does that little upside down, this thing, what am I doing each time? It means divide. It's like an upside down division. Okay, that's one way to get all of my prime numbers. Well, there's another way, and you're going to get to pick the way you like, okay? I just want you to find one that you like and get really good at it. All right, same thing. I start with the number that I'm factoring, 600. Instead of doing the upside down wedding cake method, I just list, it's like a factor tree. So 2 times 300. And then I circle my prime number 2. That is a weird looking 2. There we go. Okay. Circle the prime number. Then I can still factor down 300. I can do 2 times 150. I circle my prime number. Then I divide 150, 2 and 75. Circle my prime number. Then I break apart 75. So I have 5 and 15. Circle my prime number. And then I break apart 15 so that it's 3 times 5, and both of these are prime. So do you see how I still have the same numbers? Either way, I end up with the same prime numbers.
Does it matter which one you put? 3, 4, 5?
Nope. Because here's what we're going to do now. This is how I write my prime factorization. This is your last step.
I really like it.
This is your last step. You remember exponents and powers? It's all coming back. It's all coming back to me now. Here we go. I'm going to count how many 2's I have. And I go least to greatest. So I find my smallest number that I have out of all of the numbers listed, which is 2. How many 2's do I have?
3.
So that's 2 to the 3rd power. Okay, I've used my 2's.
Okay, cross out the 2.
What is my next smallest number? Everly. 3. So I'm going to multiply it by 3. Do I need to put to the 1st power, or can I just put times 3? I can just do times 3. And then after I use that, I have 2 5s, so it's going to be times 5 squared. Okay, that is prime factorization. Do you remember seeing that on your test review? Yeah. Okay. Okay, now you know how to do this. So you have 2 to the 3rd power times 3 times 5 to the 2nd power. Okay, here are some more. We're going to do one together, and then I'm going to let you do the other 2 with your groups so that y'all can kind of practice. They're set up as the upside down division or the upside down wedding cake version. But if you like the factor tree off to the side or down below or somewhere else, you can draw little factor tree lines if you would rather do that. Okay, so we'll do 32 together. Since 32 is even, I can divide it by 2. What's 32 divided by 2? 16. Divided by 2 again. 8 divided by 2 again.
4.
Divided by 2 again. 2. So how many 2's do I have?
5.
So it's going to be 2 to the 5th power.
Yay, good job, guys.
Okay, you and your group mates at your tables, I want you to try the next 2. Factor them down and figure out the prime factorization. What did you get?
66 divided by 33, 11 by 33.
What?
But if you did 66 divided by 11, you would have 6 underneath it because it's 6 times 11 would...
Oh, I meant...
And so then you should still end up with, even though Cooper did it differently, guys, did y'all hear what he said? So he put 11 here and then got 6 here. And then did 6 divided by 3 or 6 divided by 2, and then the other number would be here. You're still going to have all of these 4 numbers on the outside. They're just in a different order. Okay? So there's not a right or wrong way to do it, as long as you're dividing by a prime number. All right. Okay. So here I have everything down at the bottom after you factor everything down. Any questions? Yes. Nope. Okay. Yes.
I got 72 divided by 2.
72 divided by 2.
And then 36 divided by 3.
Okay.
12.
Uh-huh.
12 divided by 2 is 6. And 6 divided by 2 is 3. That's what I got.
You still end up with all the same things, right?
Yeah, well, I don't have... I had 2 to the 3rd power times 3.
Okay, so he's saying he did 36 divided by 3? Okay, so if we did 36 divided by 3, that would be 12. And then 12 divided by 2, which is 6. And then 6 divided by 2 is 3. So see, I just switched. All you did was you just had these backwards. You still have 2 3s. Did you put your 3 at the bottom?
Oh, yeah. I forgot you had to add this.
So again, he did his a little differently, which is fine. You just need to make sure that you still count everything up. And don't forget this guy at the bottom. Okay?